Okay, we are going to be maximizing a standard maximization problem. And we know it's standard maximization because as we look at the linear constraints, we notice that they are less than or equal to constraints with a positive constant. And we also have our non-negativity constraints so that the variables are all greater than or equal to 0. To set up a standard maximization problem, we can jump right to the initial tableau. If we make some observations about the original system, notice that there are two constraints. That tells us that we know there are going to be two slack variables. We also notice that there are three variables, and therefore we will have three non-basic variables throughout the process. And so when we set up our initial tableau, we can start with x sub 1, x sub 2, x sub 3, and now two slack variables, s sub 1, s sub 2, and our variable to be maximized, which is z. And we'll leave a column for the constant values. Now, our first row will be our first constraint, where we will add a slack variable to pick up the slack. We'll add an s sub 1 here and add an s sub 2 here. Therefore, we get 1, 3, 2. An s sub 1, the first constraint won't have an s sub 2 or a z value, but it does have the constant 10. The second constraint gives us the coefficients 1, 5, 1 for x sub 1, x sub 2, and x sub 3. There is no s sub 1 variable, so its coefficient is 0. There will be an s sub 2 variable with a coefficient of 1, no z variable, and a constant of 8. We also need to rewrite our objective by moving all of the terms to the same side as z. In other words, that's negative 8x sub 1 minus 10x sub 2 minus 7x sub 3 plus z equals 0. Translating that into the last row of the tableau, we get negative 8, negative 10, negative 7. There is no slack variable, s1 or s sub 2. We have z, which is 1, and the constant is 0. Now the other markings here are just to help us identify the important parts of our tableau. It separates out the last row, which will be used for observation purposes, and the last column. Now, we know we're not optimal because we have a negative entry in the last row. So we must perform a pivot operation. To decide where to pivot, we identify the most negative indicator in the last row, and that would be the negative 10. Therefore, we know that we will be pivoting in the second column. To find out whether we pivot on the 3 or the 5, we must come up with the corresponding ratios by taking the constant and dividing it by the entry in the pivot column. So our first ratio is 10/3, which is 3 1/3. Our second ratio would be 8/5, which is 1 3/5. The smaller of those two, and actually we're looking at the smallest non-negative entry of these two, would be 1 3/5. That's an indication that the 5 is the pivot element. So let's pivot then on the 5. Okay, so to pivot on the 5, we need to make the 5 a 1, and the other entries in that column a 0. So from the row operation notation from a previous chapter, we saw that we could multiply the second row by 1/5 to make the 5 a 1. So notation would be 1/5 times row 2 stored into row 2. That is now going to be a 1. Once it becomes a 1, we can eliminate the 3 and the negative 10 by taking a negative 3 times row 2, adding that into row 1, and storing that into row 1. To make the negative 10 a 0, we would take 10 times row 2, add that into row 3, and store that into row 3. Again, that should make the second column a unit column where the pivot element becomes a 1. So this is the notation we used previously. Let's see what that would look like if we're going to enter that into our calculator. To do the multiple operation, we will use the times row function. And let's assume that we have entered in our matrix into matrix A. In that case, we would say times row 1 divided by 5, comma, matrix A, row 2. To do the add a multiple operation, we would use the times row plus function of our calculators, and the first parameter would be the multiple of negative 3, the matrix that we're operating on, the row that we'll multiply by, and then the row that we'll add into. It occurred to me also we don't want to forget to store this result into matrix A after each operation. Okay, the third operation would be times row plus 10. Use matrix A, multiply 10 by row 2, add that into row 3, and store that into matrix A. After performing these operations, either by hand or by using the row operations of our calculator, we should get the following tableau.